which is integration. Okay, so I believe this is I think it's a core subject lah for everyone, because I believe in calculus 1, basically the two main topics regarding those fundamental theorem is about calculus, which is I would say differentiation and integration lah. So basically every mathematics we can run out of differentiation and integration. Okay, so okay, all right, here. Okay, so before I'm gonna start, so basically I think all of you should just ask yourself basically what is mean by an integration. Apa maksud integration? But I'm sorry that I sebenarnya dah lupa bahasa Malaysia integration, what is mean by that, because during my zaman memang saya guna bahasa English lah So integration, so you should understand and ask yourself what is mean by integration. So integration basically is the, I would say, the anti-derivative lah. Sebenarnya dia berkaitan dengan derivative. So which I believe in the previous chapter, sebab sebelum ni saya pun pernah mengajar subjek ini. So sebenarnya when I look it back, basically in the previous chapter kita dah pernah belajar tentang derivative of a function. So derivative of a function basically maksudnya macam ni lah basically we have this one d dx. Alright, so basically this one is mean by I would say derivatives describes the instantaneous rate of change of a specific function in one point. Maksudnya, for example, we are studying a rate of change, alright, or we can say katakanlah in real life lah. Okay, for example, a very simple example is actually, for example, distance. So kita tahu distance itu jarak. Okay, how about if we want to study the rate of change of a distance? So the rate of change of a distance basically is called the speed lah. Okay, tapi itu adalah di one of the example lah, and rate of change of speed is actually equals to the velocity lah. So that is what we rate of change of distance is speed. Okay, rate of change of speed is the acceleration. Okay, so that is the rate of change, or we say that it is a example of derivative. Yeah, okay, so as what I mentioned just now, derivative describes rate of change of a function with respect to one parameter, another parameter lah. Okay, so how about if kalau kita nak fikir secara reverse thinking? So meaning to say, we know differentiation of something, let's say differentiation of A, you will get B. So how come if let's say you want to get the A from B? So macam mana kita nak dapat balik A daripada B? So actually that the process is called integration lah. Meaning to say, in other words, we can say that integration is the process of how to recover a function from its derivative daripada sini ya. Okay, so for example here I make it clearer. So suppose that we have the f prime x is actually equals to 4x squared. So what is the fx? So now we have been given the derivative f prime x sama dengan 4x squared. So macam mana kita nak dapat balik fx? So that is all about integration. So it's the reverse process, how to get. So from this case, okay, later on we will go in deep lah. Macam mana kita nak dapat integration of an algebraic function, okay, integration to get a log function, a logarithm function, or how to get an exponential function, or some techniques lah about integrations. Yeah, okay. So for example, come back to this one. Okay, f prime x is equals to 4x squared. Okay, f prime x equals to 4x squared. So if we try to find the reverse process, basically we are going to find back what is the integration. Yeah, so integration with respect to dx, meaning to say kalau kita nak dapat balik fx is actually equals to the integration of 4x squared with respect to dx. And how we are going to integrate? So basically we are going to get 4x. So here the power of x is 2. So we have to add by 1 divided by actually the power lah, which is 2 plus 1. And don't forget we have to plus a constancy. And later I will explain to you why we need to add the constancy here. So before that, so we should get the correct answer for this is actually 4/3 x to the power of 3. Okay, so now if you double check with this answer, basically katakanlah you nak differentiate balik 4/3x cube, basically you are going to use the power rule, which is sorry cursor saya tak berapa jelas. Okay, so 4/3x cube. So kalau kita nak differentiate this thing, basically we are going to use back the power rule. Okay, power rule means we drop down the power, x to the power of 3. So we drop down the power, we were going to get 3, multiplied by the constant 4 over 3, and x to the power of 3 minus 1. Meaning to say you are going to get back, cancel off, you will get 4x squared. So that is how we can get it back, 4x squared. So thus, in summary for this, kalau kita nak integrate, okay, a specific function, basically we are going to get back, alright? Kalau kita nak differentiate lah, meaning to say, f prime x sama dengan 4x square. So kita nak dapatkan balik fx, we have to integrate it. Okay, so it's the reverse process of the differentiation. Okay, so this is the graphical representation lah. Dan sebenarnya ini saya ambil daripada sebenarnya nota daripada UiTM juga lah, sebab dia lagi close to your notes. I hope it will help you have a better understanding. Okay, so here I believe all of you can see here. Okay, so this is why. So if we perform a differentiation of this, we are going to get dy dx. But how about if we want to get back y from dy dx, then we have to integrate to get it back y. Okay, so this is the process called integration. Okay, all right, so now we go in deep, okay, section by section, yeah? So 4.1, the first section of this chapter is about antiderivative. So seperti yang kita telah bincang tadi, so the process of recovering a function from its derivative is called the inverse operation of differentiation. Therefore, it is called finding the antiderivative. Okay, dy dx is we are finding derivative of y. So if now we are finding antiderivative, that means it's the process of integration. Okay, so now we talk about this one. Okay, so ini yang sebenarnya slide yang saya nak explain and share with all of you. Kenapa kita kena campur C apabila kita perform integration? Okay, it's because of this one. We look at this. So suppose that, okay, we have the fx equals to 4x cubed. All right, so we know that. Therefore, kalau macam tadi lah, okay, if we want to get the antiderivative, all right, meaning to say kita integrate 4x cubed with respect to dx, we are going to get integration of 4x 3 plus 1 over 3 plus 1, which is actually, we are going to get is actually 4x to the power of 4 over 4. So cancel out, we are going to get x to the power of 4. Okay, but if you look at here, all right, kalau kita tengok semua fungsi yang mention kat sini, gx is equals to x to the power 4 plus 3. hx is x to the power 4 plus 14, and ix is equals to x to the power 4 minus 3, and jx is actually x to the power 4 minus 24. Basically, for these four functions, g, h, I, and j functions, if you perform the differentiation, all right, you perform the differentiation of all these four functions, basically will leads you to the same answer. Meaning to say, you are going to get, all right, no matter it's g or h or I or jx here, if you differentiate, basically you akan dapat jawapan yang sama, which is 4x cubed. Okay, because why? Because the constant behind, basically, if you differentiating a constant with respect to x, any constant, yeah, constant. Differentiation of any constant with respect to x, basically you are going to get back 0. Okay, in that case, therefore, we have to plus c at behind. Sebab kita campur dengan apa-apa constant pun, kalau you differentiate it, dia akan jadi kosong for the constant. So therefore, integration, after the integration process, we must add a constant. Because if we differentiate the constant, we are going to get back 0. Okay, so that is why after the integration, jangan lupa untuk tambah C dekat belakang. Okay, so that is the concept, okay, and why we have to add a C constant there. So you can see here in general, okay, expression of x to the power 4 plus c. Macam sinilah GHIJ, both these four function, dia adalah x to the power 4 campur a arbitrary constant of c. So, kita tak boleh kata salah satu dia adalah bukan antiderivative. Sebab kita tahu, no matter how, as long as dia plus or minus a constant, basically, it will be serving as the antiderivative of x to the power of 3. Okay, so this is, we call it as the process lah, okay, the terminology of antiderivative. Okay, and here, usually, pelajar akan rasa comparing differentiation and integration, basically, semua pelajar lah, okay, akan rasa macam integration lagi susah daripada differentiation. And this is a normal situation, yeah, because integration, it sometimes needs a reverse thinking process. You kena fikir, saya kena differentiate fungsi apa supaya saya dapat fungsi ini. So the process of thinking backwards or the reverse thinking skill is one of the challenge among students juga lah. Okay, next we go to 4.2. So 4.2 is about the indefinite integral. Okay, so indefinite integral, this one is also very important, yeah? So you can see here the definition of indefinite integral, yeah? So a set of all antiderivatives of the function fx is called the indefinite integral of f with respect to the x, denoted by inilah. So basically sini macam tak berapa jelas actually there is a fx, integration of fx dx. So kita guna simbol ini sebagai integral symbol, integration. Okay, and kalau differentiation we use d over dx lah, atau kita guna prime sometimes, okay, as the differentiation. But for the integration, we are using the integral symbol. Okay, so in this case, we know lah the x is the variable of the integration. Okay, just like macam tadi saya kata lah, rate of change. Okay, let's say dy dx. So dy dx is basically can be widely used to find, for example, the gradient or a slope of a function lah. So the slope or gradient of the function, so basically dy dx lah. Okay, tak semestinya nak dy dx. Kalau you nak dy dt pun boleh juga. Okay, meaning to say ini differentiation, balik kepada differentiation. So ini maksudnya rate of change of y with respect to x. Okay, kalau ini maksudnya rate of change of y with respect to the t. So now, kalau in this case, kita kata the y is actually the dependent variable lah. The t is actually the independent variable. Okay, so kalau in this case, y adalah dependent variable, x adalah independent variable. Okay, so, okay, balik kepada sini. Okay, patah balik kepada sini. So, we know that, alright, from section 4.1, basically if, alright, if f prime x is equals to fx for all x, then we know that if we integrate it, both sides, so basically we are going to get back the fx plus c lah, okay? Because integration of f prime x with respect to dx, you akan dapat balik fx, okay? So, meaning to say, but don't forget to plus a c here, sebab c is an arbitrary constant. Okay, so therefore, the differential expression, okay, of dfx over dx equals to f prime x is equivalent to the integral statement of this one. Okay, integration of f prime x dx is equals to fx plus c. Okay, so so far boleh bawa ke semua orang? Kalau boleh bagi some response to me, because it seems like using Google Meet I cannot see any thumbs any response lah. Okay, I macam tak boleh nampak kalau guna Webex, guna Teams macam boleh nampak. So I'm not pretty sure whether all of you are okay with this. Boleh ke? Semua boleh bawa ke? Boleh faham ke?
Boleh.
Boleh no problem Alright, thank you very much for your response. Okay, so next, alright, we come to the formula. Alright, we come to the formula. Okay, of course, kalau differentiation kita ada formula. Of course, integration is the reverse process, actually the same thing lah. You refer balik sahaja sebenarnya. Okay, for example ini sebenarnya saya pun sebenarnya ambil daripada nota daripada UiTM juga. Okay, so for example, kita tahu kalau differentiation of x with respect to x, kita akan dapat 1. So therefore, kalau saya integrate dx, saya akan dapat balik x plus c. Or you can say like this, actually is integration of x to the power of 0 dx. X to the power of 0 is actually 1. So therefore, if you integrate this, is basically you are going to get x to the power of 0 plus 1 over 0 plus 1. So meaning to say is actually x to the power of 1 over 1. So it's x lah, and don't forget to plus a c here. Okay, so this is the thing that I believe all of you already understand this, and perhaps some of you are very familiar with this. Dan memang terror lah part ini. Okay, so just not let you know, if you refer to this table, differentiation of A, kalau you get B, it means that integration of B, you akan going back to get back the A. Alright, so for example this one lah, ini pun saya rasa memang dah understood. Alright, kalau kita differentiate x to the power of n plus 1 over n plus 1, kita akan dapat x to the power of n. Okay, so meaning to say kalau kita integrate x to the power of n, kita akan dapat balik x to the power of n plus 1 over n plus 1. N plus C lah. And of course, the N cannot be equals to negative 1 lah. Sebab kalau negative 1 plus 1 at the denominator, basically you are going to get 0, which is actually you are going to get it undefined. Okay, so next is about the third one. Okay, the third one is basically the differentiation of ln x. Okay, differentiation of ln x, semua orang tahu sebenarnya kalau kita differentiate ln x, kita akan dapat 1 over x. Okay, but here, sometimes when I ask my students, alright, even for some students taking engineering courses or even for our own department students, kadang-kadang kalau kita tanya, kenapa? Kita tahu differentiation of ln x kita akan dapat 1 over x. Tapi kenapa differentiation of ln x dapat 1 over x? Macam mana? So sebenarnya, kalau kita nak proof lah, okay, proof differentiation of ln x is equals to 1 over x. Basically, you can, for example lah, let's say I let y sama dengan ln x. Proof now is proving kenapa differentiation of ln x you dapat 1 over x. So suppose that we let the y is equals to ln x dulu. Okay, so exponential y is equals to exponential ln x. Maksudnya you akan dapat x lah dekat belah kanan sini. Okay, next what we do, we perform the differentiation from both sides. Meaning to say, let's say dx exponential y equals to d over dx x. So from here, we know that the right-hand side is definitely 1 lah. Sebab differentiation of x with respect to x, you akan dapat 1. So differentiation of exponential y with respect to x, you are going to get back exponential y, but you have to add with dy dx. Okay, so therefore, dy dx is basically equals to 1 over exponential y. And what is exponential y? Basically, our exponential y is actually the x. So therefore, we will get that dy dx is equals to 1 over x. Okay, so this is how and kenapa kalau kita differentiate ln x, kat sini. So, kita akan dapat 1 over x. Itu sebab dia. Okay, so therefore, kalau kita nak integrate 1 over x, so kita akan dapat balik ln x plus c lah, which is here. Okay, so what if kalau integration of ln x? Okay, sekarang ni, maybe a take-home message for you lah. Because when I read through your, how to say, the syllabus lah. Okay, saya dah tak ingat dah specific term dekat UiTM. Apa? Syllabus lah, okay, syllabus. So, integration of ln x sebenarnya macam tak ada dekat syllabus. Alright, so integration of ln x, basically you have to use the integration by parts lah. Okay, but when I look through the syllabus, it seems like integration by parts is not included in the syllabus. So perhaps everyone, you can try to explore this as your take-home exercise. Kalau saya nak integrate ln x, apa yang saya akan dapat? Okay, so that one I leave it as your take-home message. Okay, so now the next, okay, ini sebenarnya saya rasa saya boleh just glance through lah, okay. Sebenarnya ini saya rasa korang dah memang faham. So differentiation of cos, you get negative sign. Therefore, kalau integration of sign, I'll get back negative cos. Okay, so integration of negative sign, saya dapat positive cos. Okay, sama je kalau constant, you can take in front or you can just implement it lah, okay, for the constant, ya. Okay, sama juga kalau kat sini integration of cos, you akan dapat sin x plus c. Integration of secant x, you akan dapat tangent. Sebab differentiation of tangent, you dapat secant square. Okay, so same goes to the remaining one lah. Okay, and one more is about the last term, which is the exponential. So the exponential, we know that differentiation of exponential x, we are going to get back exponential x. Okay, so therefore, kalau kita integrate balik, sama juga kita akan dapat exponential x plus c. Okay, alright, just for example lah, okay, kalau kita differentiate the exponential negative 2x. So kalau kita differentiate, basically, we are going to get negative 2 exponential negative 2x. Kalau kita differentiate lah So kalau kita integrate negative 2 exponential negative 2x respect to dx, kita akan dapat baliklah exponential negative 2x. Okay, so that is the table of formula lah, okay, that you can always refer, yeah. Okay, I believe you will get lah, you will get the table of formulas during your exam, so you can always refer lah, okay. So next, we move on to integral involving a constant, a to x to the power of n, and also ax plus b in a bracket to the power of n. So we go one by one. So as I mentioned, this one is taken from your notes. So hopefully you can always now, sekarang you boleh juga buka nota you boleh sama-sama refer lah, okay? So constant. So if we want to integrate a constant k, let's say a k is a constant with respect to dx. So we know that kalau integrate with a constant, kita hanya campur dengan x. Maksudnya you boleh buat macam ni juga. Integration of x to the power kx to the power of 0. So kalau kita nak integrate with respect to x, sebenarnya k tu constant. So we can take it out the constant. So it's actually kx to the power of 0 dx. Meaning to say you will get kx to the power of 0 plus 1 over 0 plus 1 plus c. So meaning to say sebenarnya you akan dapat kx plus c lah. Okay, that is how. Okay. Next, kalau integration of k with respect to du, apa yang kita akan dapat? Sekarang ni sebenarnya sama je, masih integration involving a constant, but now we are integrate with respect to a u, a variable u, not a variable x. So kita akan dapat, in this case, we are going to get ku plus c. Okay, no x because we are not integrating with respect to the x, but we are integrating with respect to the variable u. Okay, so hopefully you can score this one lah. Okay, this one I hope you can get it. Okay, next is actually an integration of ax to the power of n dx. So in this case, kalau kita integrate a and then you have x to the power of something, basically what you need to do is basically the power of the x you campur dengan 1 and then you divide by the n plus 1. Okay, and of course lah, once again, the n cannot be negative 1, because the denominator once becomes 0, basically it is undefined. Sometimes you need to use, not sure lah, depending when the limit occurs, so you have to use the L'Hopital rule and so on lah, if let's say it is in the indeterminate form. Okay, so this one is actually, I think quite, macam mana cakap, straightforward lah. So let's say I have integration of 3x to the power of 4, alright, x to the power of 4. dx. So in this case, what we are going to have, the a, the constant, you take it out. It's just a constant. And x to the power of 4, kalau in this case, kalau you compare dengan formula, 4 itu adalah n lah. So 4 plus 1, you akan dapat 5 kat sini. Over n plus 1, which is 5. And then don't forget to plus c here lah. Okay, so that is the case lah. Alright, so same goes to, kalau kita dapat, katakanlah integration of 3 exponential negative 1, katakanlah, dx. So in this case, kebanyakan students, dia akan buat macam ni. 3, dia akan equals to 3, and then x to the power of negative 1 plus 1 over negative 1 plus 1 plus c. But when this happen, you can see, negative 1 plus 1 at the denominator, you akan dapat undefined, which actually this integration is not converging. So meaning to say, jawapan dia memang tak valid. Okay, so basically this is wrong. This is wrong because here the denominator is actually equals to 0. So what is the correct answer? Basically, you have to go back just now. If we integrate 1 over x, okay, here, all right. So integrate 3 over x dx. So basically, you are going to get integration of 1 over x, you are going to get ln x, which is 3 ln x plus c. Okay, so this one, I believe you can also understand lah, but I try to, kadang-kadang saya akan highlight lah some of the common mistakes among students. So when you see x to the power of negative 1, basically is related to ln. Okay, so that's the case lah. Okay, kalau you tak percaya, you boleh differentiate balik. Kalau differentiate, basically differentiation of ln x, you get 1 over x. So it's 3 over x. And differentiation of c, you get 0 lah. So it's 3 over x, which is 3x to the power of negative 1. Okay, so that's the correct answer for this lah. Okay, the next example. Okay, next example lah, number 3. So is a, if you have ax plus b to the power of something, to the power of n, then what you are going to do is, all right, let me erase this one first. Perhaps I erase this one first. Okay, so meaning to say, for this one, suppose that you have integration of ax plus b to the power of n with respect to dx. So basically, what you are going to do is you copy down, everyone. You just copy down ax plus b to the power of n plus 1 divided by n plus 1. But one more thing that you should bear in mind, katakanlah coefficient in front of x ini bukan 1. Katakanlah dia adalah 2, atau 1 over 2, atau 1 over 3, atau 100. Basically, you have to multiply by the A. Actually, you can also say it's actually differentiation of the things inside the bracket. Okay, so differentiation of the things inside the bracket, meaning to say kalau you differentiate ax plus b with respect to x, what you are going to have is actually A. Alright, so that is how we can deal with this. Okay, so for example lah, okay, sama juga saya bagi satu example lah. For example, we have integration of 1 over 2. Okay, 1 over 2x minus dx. So what you have to do, everyone, mula-mula you copy down je 1 over 2x tolak 3 to the power of, sini the n is 3, right? So n plus 1, that means 3 plus 1 is 4, over n plus 1, again is 4, and multiply by the differentiation of the things inside. So differentiation of the things inside, you get 1 over 2. Okay, so basically 4 divided by 2, basically you get 2 lah. Okay, you dapat 2 lah. So basically you are going to get like this. Alright, you are going to get like this. Okay, so kalau you nak further simplify, you can simplify lah. But actually you can get this answer is already considered correct. Okay, and don't forget to plus a C here. Okay, all right, so that's the integral of the constant and also the things lah, okay, the algebraic function, yeah. Okay, so now without further ado, so now is what time? Oh, 3:40 already. Okay, perhaps I go a little bit faster because later on I might explain to you the application of integration as well if the time allows lah. Okay, so now we look at example number 1. We discuss example by example so that you can absorb it better lah. Okay, so basically for the first question, integration of 92. Yeah, everyone. Okay, so integration of 90. Okay, all right. So integration of 92 with integration with respect to x. So as I mentioned, kalau it's a constant, basically what do you have is actually you just 92 and then x plus c. Still remember, you can treat it as x to the power of 0. So x to the power of 0, you are going to have integration x to the power of 0 with respect to dx. Basically is integration x 0 plus 1, which is positive 1 over 1 plus c. So basically you will get x to the power of 1 over 1 plus c. Maksudnya x plus c lah. So suppose that we have 92 in front, basically we are going to get 92x plus c. Okay, so that's the correct answer for example number 1, yeah? Okay, so how about example number 2? So example number 2 is also very, very straightforward when we have integration of square root 4 with respect to du. But here, as I mentioned, I just want to make a revision. Just now I mentioned to you, you have to look at the variables that you want to integrate with respect to. So in this case, your answer is square root 4 and then with the u, not the x, plus c. Because now in this case, we are integrating with respect to the variable u. Okay, so it's square root 4 u plus c. Okay, all right, second answer provided to you. Okay, how about the third question? So the third question is 3 over 8, integration x squared dx. So again, in this case, we are integrating with respect to the x lah. So now you will get 3 over 8, all right, x to the power of 3, because 2 plus 1, right? 2 plus 1 is 3, over 3 plus c. And therefore, you can further simplify. The 3 and 3 can be cancelled out. You will get x cubed over 8 plus c. Okay, so that's the correct answer for question number 3. Okay, next. All right, so question number 4. Question number 4. Let me erase. Okay, question number 4. Integration of 1 over square root of 2x plus 5 with respect to dx. So now, everyone, you look at this question, especially for those you are still not very clear about how to deal with the integration. So you can have a look at this question. Perhaps 3 seconds. Okay, you look at this. Dan you fikir, macam mana saya nak start? Okay, basically, I would suggest lah, okay, kalau dia ask, maksudnya soalan di given is still in the algebraic function. Basically, so we have to modify a little bit in terms of the power. So kita tahu kalau is 1 over something, so for example lah, 1 over x is actually equals to x to the power of negative 1. Okay, so how about if 1 over, okay, atau saya tanya macam ni dulu. Okay, square root x. Square root x is actually x to the power of half. Alright, so combining these two properties, then you should know if 1 over square root x is actually x to the power of negative half. Alright, so in this case, alright, come back to question number 4. So integration of 1 over square root of 2x plus 5 is actually 2x plus 5 to the power of negative half. Okay, with respect to dx. Alright, so now kalau kita modify a little bit of the questions, okay, so not the modifier, but we try to modify into the forms that we want lah. Okay, so then the question will become crystal clear. Okay, so integration of 2x plus 5 to the power of negative half. So now what you have to do is just copy down 2x plus 5 to the power of negative half is the n plus 1 divided by the negative half plus 1. Alright, and don't forget, if the coefficient here is not positive 1, all right, so what you have to deal with is you must differentiate the things inside the bracket with respect to x. Kalau kita differentiate 2x plus 5 with respect to x, kita akan dapat 2 dekat sini. So meaning to say, the complete answer, don't forget to plus c, yeah? So you can see here, negative half plus 1 is half. Half multiplied by 2 is positive 1. So therefore, here is actually negative half plus 1, right? So definitely you will get your answer is square root 2x plus 5. Plus C. Okay, so this is the correct answer for question number 4. Okay, so if you don't believe, everyone, you can try to double check. Always try double check with the answers by differentiating your answer. So ini yang you kata jawapan kan? So if we try to differentiate to square root 2x plus 5 with respect to x, apa yang you akan dapat? So sebenarnya kita dah tahulah dia adalah 2x, or like this, 2x plus 5 to the power of half. So, kalau you nak differentiate, you can use the power rule lah. You can drop down the power, you will get 1 over 2, and then 2x plus 5, and then 1 over 2 minus 1, you will get negative 1 over 2, and you have to multiply by the differentiation inside the bracket, which is 2. So 2 and 2 can be cancelled out, you will get 2x plus 5 to the power of negative half, which is 1 over square root of 2x plus 5. So this will be the correct answer, same as the original question here. Okay, so this will be the correct answer. Okay, so now everyone, so before I proceed further, all right, okay, before I proceed further, so can all of you follow? So far boleh follow ke? Okay ke?
Boleh.
Okay.
Okay, that's great. Okay, so okay, baik. Thank you for your response. Okay, so now we look at the next example. Okay, example number 2. Soalan dia akan semakin challenging a little bit lah. Okay, semakin challenging lah. So hopefully you can still can catch up lah. If you can't catch up, you just let me know, yeah? You can just stop me. Okay, so now we go to example number 2, which is integral involving algebraic functions. Okay, so now we go one by one. Question 1. Okay, integration of 3 square root x minus 1 over x to the power of 4, all right, with respect to dx. So in this case, sebenarnya, kalau you nak guna the linearity property lah, basically you boleh dapat je integration of 3 root x dx minus integration of 1 over x to the power 4 dx. Okay, ini understood lah, okay, ini linearity property. Tapi kalau you tak nak buat macam ni, you boleh terus tengok je, you dah boleh buat sebenarnya. So kalau integration of 3 square root x basically is actually x to the power of half, right? So basically you are going to get x to the power of half plus 1, which is 3 over 2 divided by 3 over 2. Okay, I write lah, Okay, so meaning to say is 3 and then x to the power of half, all right, plus 1 over half plus 1. Okay, minus, this one is actually x to the power of negative 4. So x to the power of negative 4, basically you are going to get negative 4 plus 1 over negative 4 plus 1 plus c. So what's your correct answer? Therefore, your correct answer, if you look at here, 1 over 2 plus 1 is actually 3 over 2. Kalau you divide by 3 over 2, that means you multiply by 2 over 3. So you are going to get 2 here lah. Okay, you are going to get a 2 here. X to the power of half plus 1 is 3 over 2. Okay, minus, here is negative 4 plus 1. So it's actually negative 3 over negative 3 as well. So here will become positive lah. Will become positive over 3. Okay, plus c. Okay, or you can write like this lah. It's actually 2, all right, to the power of square root of x cubed plus, all right, this one is 1 over 3x to the power of 3 plus c lah. The same answer. Okay, so this will be the correct answer for question number 1 in example 2. Okay, all right, so hopefully you can catch up. All right, if you cannot, let me know. Okay, now settle question number 1. Okay, so we go to question number 2. So question number 2 is 3u minus 2, the whole thing to the power of 2. Okay, so now in this case, let me erase for this one. Okay, so harap korang boleh salin lah, okay? Boleh salin lah, boleh follow my slides and you can try to write it down again, Okay, so now we go to this one. Question number 2. Okay, question number 2. Question number 2 is integration of 3u minus 2 to the power of 2 with respect to du. Okay, so in this question, okay, basically dia ada dua cara boleh buat. Okay, kalau you nak guna power rule boleh, kalau you nak expand pun boleh. Alright, so for example, okay, I take this. Let's say I use the simplest way lah. The simplest way is definitely the, the straight away 3u minus 2 and then to the power of 2 kan. So dia akan jadi 2 plus 1 over 2 plus 1. Okay. Multiply by differentiation of the things inside the bracket with respect to u. So definitely you are going to get 3 here lah. Okay, plus c. So meaning to say in this case, what are you going to have is actually 3u minus 2 to the power of 3 over 3 darab 3 is 9. Okay, it's 9 plus c. So this will be a straightforward method. Okay, straightforward method. So this is also correct. Tapi kalau sometimes students kata, boleh tak saya buat macam ni? 3u minus 2 multiply by 3u minus 2 with respect to du. Sebenarnya boleh je, tak ada masalah. So meaning to say, kalau if you integrate, you are going to get 9u square and here is minus 6 is minus 12u plus 4 with respect to du. So basically, you are going to get 9u to the power of 3 over 3 minus 12u square over 2 plus 4u plus c. So definitely, you are going to get is actually 3u cubed minus 6u square plus 4u plus c. Okay, so this will be also the correct answer. So now, you akan tanya saya, kenapa ada dua jawapan? Sebenarnya, if you referring here, this answer, kalau you expand dia, you expand 3u minus 2, multiply by 3u minus 2, multiply by 3u minus 2, over 9, basically you akan dapat jawapan yang sama. Tapi, mungkin you punya constant kat sini mungkin akan lain sikit. Dia akan dapat campur something, campur dengan C. But actually that is not going to affect our answer because no matter how, if we differentiate the constants with respect to the U, we are going to get 0. Okay, so in this question number 2, basically both answers are accepted, are both correct. Both are correct. Okay. All right, so this will be the discussion lah for question number 2, Okay, so now let me go to question number 3. Okay, question number 3 again, Okay, so question by question, hopefully you can have a better understanding lah, okay? Okay, question number 3. All right, so integration of 2x to the power of negative 2 plus 1 over square root x. So, kalau you dah biasa, you terus buatkan dia x to the power of negative half. All right, with respect to dx. So now if you integrate, you'll get 2x to the power of negative 2 plus 1 over negative 2 plus 1 plus x to the power of negative half plus 1 over negative half plus 1 plus c. So definitely what you are going to have is 2x to the power of negative 1 over negative 1. So it will become negative lah. Okay, plus here is negative to the power of half over negative, over half. Okay, so over half, it means that multiply by 2. So multiply by 2, x to the power of half plus c. Okay, so this will be the correct answer, Or you can write negative 2 over x plus 2 square root x plus c lah. So this will be the correct answer for question number 3. Okay, question number 3, Okay, so alright, so I believe benda sama je. So saya rasa korang boleh bawa. Kalau tak boleh bawa, sila open your mic and tell me. Okay, so question number 4. Okay, question number 4, what you have to do is basically, you can see here, is actually integration x to the power of 1 over 3 minus 3. over x to the power of 2 over 3 dx. Okay, so in this case, all right, basically students kadang-kadang mungkin lah ada some of the students when they look at this question, they might start for a few seconds. All right, so but the correct way is, first of all, you ingat satu je. You try to simplify the equation. You try to simplify the function, the equation. All right, okay, not the equation, the function. All right, you simplify the function first before integrate. So in this case, sebenarnya we can see the denominator is x to the power of x 2 over 3. So it means that kalau kita break it down, okay, so you will get x to the power of 1 over 3 over x to the power of 2 over 3 minus 3 over x to the power of 2 over 3 with respect to dx. All right, so meaning to say is actually x to the power of 1 over 3 minus 2 over 3, you will get negative 2 over 3. Okay, and this one is negative 3x to the power of negative 2 over 3 lah. Okay, so with respect to dx. Okay, so now once you get here already, okay, wait, this one, okay, negative 3 over, okay, yes, correct. So basically, after you integrate, so what you are going to have is actually equals to x to the power of negative 2 over 3 campur 1. So you akan dapat 1 over 3 lah. 1 over 3, what you are going to have is actually 1 over 3, with negative 1 over 3. Here I make a mistake. Negative 1 over 3. Okay, here I make a mistake. Sorry, everyone. So 1 over 3 minus 2 over 3. So it's negative 1 over 3 instead of negative 2 over 3. Okay, I make a mistake here. Patutlah saya rasa kenapa sama. Okay, so kalau patah balik sini, okay, integration of x to the power of negative 1 over 3, you will get x to the power of negative 1 over 3 campur dengan 1. So meaning to say is 2 over 3. Okay, 2 over 3 and then you divide by 2 over 3. It means you multiply by 3 over 2 lah. 3 over 2. Okay, and here is minus 3x to the power of negative 2 over 3 plus 1. Again, you will get 1 over 3. And divided by 1 over 3, you will get multiplied by 3. So here is 9x to the power of 1 over 3 plus c. All right, so that will be the correct answer for this question. Okay, so that is how lah. So a tips to tell you, don't be scared when looking at the function before simplify. So you try to simplify by yourself first before you integrate. Okay, cuba untuk write in terms of the form that you are familiar before you can perform the integration. Okay, so that's the thing lah. Okay, so yeah, now is almost 1 hour already. Okay, so we go one by one because actually there are still many things to go through. Okay, so next we go to integral formulas of trigonometry function. Okay, so in this case, alright, I believe lah, kalau dalam chapter derivatives atau differentiation, basically you know already. Kalau kita differentiate sine, we are going to get cos. Okay, kalau differentiate cos, you akan dapat negative sine. Okay, sine, differentiate, you dapat cos. Cos, differentiate, you dapat negative sine. Okay, and so on lah. Okay, so the reverse process. Okay, so integration of cos, you akan dapat balik sine. Integration of negative sine, you akan dapat cos. Atau integration of sine, you akan dapat negative cos. The same thing lah. Okay, so basically I believe there should be no problem. Cuba kita tengok sini. Differentiation of tangent x, kita dapat secant square x. So therefore, integration of tangent ax over a, kita akan dapat balik secant square ax. Okay, so and so on lah. The remaining are just same and similar analogy. Okay. One more. I forgot already. In your syllabus, I'm not sure whether you have hyperbolic function or not, which is the sine x and cos x, okay, or cof x or tan x. All right. So this one basically is a little bit specialized hyperbolic function. Okay. Differentiation of sine, you get cos. Differentiation of cos, you get back sine. Okay, and actually the definition is also by exponential also lah. Okay, sine x is exponential x minus exponential negative x over 2. Okay, so not sure whether in your syllabus or not because just now kalau saya tengok macam tak terlibat dengan hyperbolic function ya. Okay, then you are safe lah. Okay, sebab kadang-kadang when it comes to sine and cos, kalau kita nak integrate, sometimes we have to use the exponential function. We have to use the definition. Okay, all right, so without further ado, we jump to the integration involving trigonometry function lah, okay? Question number 1 first, question number 1. Okay, so question number 1, sine 3x with respect to dx, integration, sine 3x with respect to dx. Okay, so mungkin ini saya pun rasa mostly mungkin banyak pelajar yang mungkin tak berapa familiar lah, masih tak berapa macam terbiasa dengan integration involving trigo. So I will slow down a little bit. So biasanya my way is saya akan macam ni dulu. Okay, integration of sine kan, sine. So kalau integration of sine, saya kena tanya saya sendiri. Integration of sine saya akan dapat apa? Saya mesti akan dapat negative cos. Betul tak? Sebab differentiation of cos saya dapat negative sine. So in order to remove the negative, saya kena tambah satu negative. Meaning to say, kalau integration of sine, I should get negative cos. Okay, negative cos. Itu first. You write down that thing first. For example here, integration of sine, you get negative cos. Alright, cos AX lah. Okay, so kalau you nak terus refer pada formula, you boleh teruslah. Ini adalah 3. So you dapat tahu is negative 1/3 cos A 3x plus C. But for me, apa yang cara saya akan advise my student to do is, you ask yourself first, kalau integration of sine, you akan dapat apa? You akan dapat negative cos. And then, you copy balik what is here. You copy balik, and then you divide by the differentiation of the things lah. Differentiation of ini. So, differentiation of 3x with respect to x, you are going to get 3. So, that's the correct answer. Negative 1/3 cos 3x plus c. Okay, so usually I will advise my student to do like that lah. Okay, so that's the correct answer for example number 1 here in example 3. Okay, how about question number 2? Integration of cos 3 minus 4x dx. So we know that, macam tadi saya katalah, cara saya sendiri ialah saya akan tanya dulu, kalau integration of cos saya akan dapat apa? Saya akan dapat sine, definitely. Sebab differentiation of sine, saya akan terus dapat cos. Tak ada negatif, tak ada benda-benda negatif lah. So, integration of cos, saya akan dapat sine. So, sine, lepas tu saya copy je 3 tolak 4x. Saya salin semula, tapi saya bahagi dengan differentiation of the things inside. So, differentiation of the things inside with respect to x, you're going to get negative 4. Okay, so that's the correct answer lah. Okay, if you want to write negative 1/4 sine 3 minus 4x plus c is also correct, the same thing. Okay, so that is how we can solve for question number 2. Okay, so now I go to question number 3, everyone. I go to question number 3. So question number 3, so basically integration of secant square 3x dx. Okay, so next lah, ask yourself, integration of secant square, you akan dapat tangent definitely. So tangent 3x. Lepas tu bahagi dengan differentiation of this thing. So you akan dapat 3 lah campur dengan c. That's the correct answer for question number 3. Okay, so next we move on. Example number 4. So example number 4, integration of sine square x dx. This one. Okay, so when it comes to this one, alright, actually there are several methods to solve lah. Okay, dia ada je several methods to solve. Okay, no problem basically. Okay, so but for me lah you sebenarnya kalau you betul-betul nak guna, you boleh guna substitution and so on lah. But for me, basically the most easiest way is to use the identity. Okay, identity. So identity, alright, so you have to search for the formulas lah. So we know that, okay, you boleh tengok lah, alright. Yang penting, kenapa kita nak guna identity? Sebab kita nak get rid of the power. Kita nak get rid of the power. Alright? So, in order to get rid of the power, you kena look at the formula list lah, or you identity lah. You have to memorize the formula. Alright? Semua formula lah termasuklah sine, okay, 2 sine x cos x, okay, is equals to 2 sine 2x, and so on lah. Cos 2x is equals to 1 minus 2 sine square x, and so on lah. Okay, so that's called identity. Yang penting, you kena tengok yang mana identity yang sesuai, yang melibatkan sine square x ini, dan the remaining terms are in the order of 1. Okay, what does it mean order of 1? Meaning to say, saya akan pilih formula inilah. Okay, identity, cos 2x is equals to 1 minus 2 sine square x. Maksudnya, saya kena pilih identity formula yang tak melibatkan sini ada square and so on. Tak ada. Tak ada sini ada square or to the power of 3 or to the power of 4 and so on. Okay, saya tak nak sebab saya memang the main objective is to remove this power, to reduce the power. So therefore, kita boleh guna formula ini sebab kita boleh gantikan sin square x ini menjadikan actually 1 minus cos 2x over 2. Okay, maksudnya daripada sini kita akan dapat macam ni lah. We shift this term to the left hand side, we shift this term to the right hand side. We are going to get sin square x is basically equals to 1 minus cos 2x over 2. So basically this is, tengok sini sekarang dah tak ada power 2, tak ada power 3 and so on because we already reduced by using the identity. So this is what I mentioned lah. Kita pilih identity yang sesuai supaya selepas substitution tu semua order akan jadi satu. Dia bukan power 2 dah, memang power 1. So meaning to say after substitution you know by using identity sin square is equals to 1 minus cos 2x dx. And here 1 over 2 you can put in front lah sebab dia adalah constant. Okay, dia adalah constant here. So basically you know integration of 1 with respect to x, you akan dapat x. Okay, you akan dapat x. And kalau integrate cos you akan dapat apa? Sin. Okay, you akan dapat sin. You akan dapat sin. Okay, 2x, and don't forget to divide by the differentiation of the things inside the cos, meaning to say is 2 here. Okay, so meaning to say this is the correct answer, and don't forget to plus the c here. So this will be the correct answer. Okay, half multiplied by x minus sine 2x over 2, and then plus c. All right, so that's how we deal with the example here lah. All right. Okay, so everyone, boleh bawa ke so far by using identity? Boleh ke? Is it okay?
Okay.
Okay, no problem. Alright, glad to hear that. Okay, so let me finish one more example. Okay, before I think we go for a break for 5 minutes lah, so that you can still refresh your mind. But later on, perhaps I go a little bit faster, yeah? Okay, so question number 5, integration of secant 2x plus 1 tangent 2x plus 1 respect to dx. Okay, so in this case, basically the answer is very straightforward lah. Sebab kalau integration of secant tangent, okay, nampak sangat memang integration of secant tangent, you are going to get back secant ax over a. So meaning to say, you are going to get secant ax. All right, what is your ax? So basically is this one lah, all right, 2x plus 1 over the differentiation of the thing inside, which is 2. So plus c. So this will be the correct answer. Sebab kalau kita differentiate secant, okay, with over a, kita akan dapat secant ax tangent ax. Okay, so that is how we can get the answer lah. But sometimes the question might be a little bit challenging lah. Sometimes dia kena guna identity. For example, kalau secant, let's say here dia bukan 2x campur 1, tapi dia 2x campur 2, katakanlah. Okay, katakanlah tangent 2x campur 1. So you have to modify this one so that it become 2x plus 1 lah. So tapi kalau macam ni biasanya you kena guna identity lah. For example, soalan ni macam susah sikit lah. Contoh macam sin lah, okay? So, you kena modify a little bit so that you can use back the identity sin A cos B, okay? Plus cos A sin B is equals to sin A plus B, and so on. Okay, so that's the identity lah. Tapi kalau for this question, 2x plus 1, 2x plus 1, basically nothing to modify. Straight away, you can apply the formula to get the correct answer. Okay, alright. Okay, so I think kita boleh rehat sekejap kot sebab saya rasa macam they need some time to absorb as well. Okay, so perhaps saya bagi sekejap je lah sebab masa macam singkat pula. So saya bagi 4 minutes break sampai 5 o'clock lah bukan 5 o'clock, sorry, 4:10. Pukul 4:10 bukan sampai pukul 5 Jangan terus keluar Okay, 4:10 3 minutes break, just a short break. Okay. Okay, everyone. So, boleh kita continue, everyone? Kalau boleh bagi sedikit response, some reaction please. Alright, before we can proceed lah. Okay. Alright, thank you very much. Okay. Wah, rasa macam semua masih bersemangat ya. Okay, alright. So, bila saya tengok sebenarnya tadi saya tengok banyak lagi slide yang saya kena discuss sebenarnya. Dan kalau sebenarnya saya nak explain a little bit of the application as well tapi macam masanya singkat lah. Okay, saya cuba untuk bergerak cepat sikit everyone. So I go a little bit faster but still if you feel like you can't understand, you can just open your mic and interrupt me. Don't be shy or don't hesitate to interrupt me. Okay, so now I go a little bit faster. So next is about the integration involving exponential function. So exponential function, basically we know lah, exponential function, exponential x, the graph is like this. Okay, so now if we want to integrate of an exponential function, kalau integrate of exponential ax plus b, basically kita akan dapat balik exponential ax plus b, but we have to divide by, again, the differentiation of the power of the exponential. Maksudnya, kita akan saling balik semua exponential, for example, kalau exponential 2x, kalau kita integrate, kita akan dapat exponential 2x, salin je, tapi kita bahagi dengan differentiation of the power, which is 2. Okay, sebab kalau kita differentiation, kita akan dapat 2 exponential 2x over 2. So, kita akan dapat balik exponential 2x. Okay, so, and don't forget to plus c, alright? So now I go a little bit faster, everyone. So question number 1, exponential x dx. Kalau kita integrate exponential x, we are going to get back exponential x over the differentiation of x, you are going to get 1. Basically, you akan dapat sama je, which is exponential x plus c. Sebab kalau differentiate exponential x, you akan dapat exponential x juga. So that's the correct answer lah. Very simple, Next, we go to question number 2, integration of exponential x plus 7 dx. So now, if we integrate, basically, just copy now exponential x plus 7, divide by, what you have to do is divide by the differentiation of this thing. Differentiation of this thing, you still akan dapat 1 juga. So, maksudnya, exponential x plus 7 plus c. That's the correct answer. Sebab, kalau you differentiate ini, you akan dapat 1. Sama je, you akan dapat balik exponential to the power of x plus 7. Okay, next we go to question number 3, integration of exponential to the power of 1 minus 4x dx. So basically, you are going to get back exponential, salin sahaja, 1 tolak 4x, tapi bahagi dengan differentiation of 1 minus 4x with respect to x. You akan dapat negative 4, okay, plus c. So that's the correct answer, okay, that's the correct answer. Okay, next, question number 4, integration of 2 minus 3 exponential 2 plus 3x dx. So again, ini sama sahaja, kalau integration of 2, you akan dapat 2x. Kalau negative 3 exponential 2 plus 3x, salin sahaja tapi bahagi dengan differentiation of this thing, which is 3. And 3 can be cancelled out, leaving only minus exponential to the power of 2 plus 3x plus c. Okay, so that's the correct answer, Okay, so question number 5. Okay, again, question number 5. Integration of exponential 5x multiplied by exponential 2x over 7 plus 3 over exponential 3x dx. So for this kind of question, first of all, sama sahaja, jangan menakutkan sendiri, but what you need to do is you try to simplify it, okay? Simplify it. So you know, in this one, you multiply inside, okay? So you will get exponential 5x plus 2x over 7. And this one, you will get 3 exponential 5x minus 3x, all right? With respect to dx lah. So basically, you will get integration of 1 over 7 exponential 7x, all right? 7x plus 3 exponential 2x with respect to dx. Okay, so therefore, you should get your answer is 1 over 7 exponential 7x over 7. So over 7, what you have is divide by 7, 7, 7, 49. Okay, 1 over 49 exponential to the power of 7x, and then plus 3 exponential of 2x over 2. So plus c. So that will be the correct answer. Okay, so hopefully all of you are okay. So if you don't have question, means you are okay to catch up ya. Okay, so saya akan bergerak ya. Okay, kalau tak ada soalan. So kalau ada soalan, sila buka mic tau. Sebab saya memang tak nampak apa-apa. I can only see my screen and annotation, but I couldn't see my face. I couldn't see your reaction. Okay, so please do not hesitate to open your mic if you have any questions to ponder. Yeah. Okay. All right. So next we go to logarithmic function. Okay, logarithmic function, yeah. So logarithmic function basically ln lah, okay. So we know, as I mentioned just now, okay, differentiation of ln, you get 1 over x. Integration of 1 over x, you will get back ln x. But now let's say you have integration of 1 over ax plus b, okay. Macam contoh 1 over 3x tolak 2 katakanlah. When you see like this, so meaning to say your answer should be in terms of ln. And what is your answer is ln ax plus b over the differentiation of the things inside, which is again the a lah. Okay, so we go to the example number 5. Okay, example number 5, question number 1, integration of 1 over x dx. So very straightforward, you will get ln x plus c. Okay, ln x plus c, yeah. Okay, so the second question, integration of 1 over x plus 8 dx. So definitely, again, this is in terms of ax plus b. So according to what we discussed just now, basically you are going to get ln x plus 8 over the differentiation of x plus 8. Differentiation of x plus 8 is 1, actually divide by 1. So basically, you don't need to write it. So that's the correct answer. So if you don't believe, kalau kita differentiate benda ni, you akan dapat x plus 8 at the bottom, and the numerator is the differentiation of x plus 8, which is positive 1. So you akan dapat balik 1 over x plus 8. Okay, all right, next we go to the third question, integration of 2 over 2 minus 3x respect to dx. So basically your answer is actually, first you write down ln first lah, ln 2 minus 3x over the differentiation inside, which is negative 3. But don't forget here, there is a constant 2. So meaning to say is actually negative 2 over 3 ln 2 minus 3x, okay, plus c. That's the correct answer. Okay, so the next question, question number 4, all right, integration of 1 over 3x dx. So kalau in this case, you know lah, you should ln 3x, all right, divided by 3. All right, so meaning to say is 1 over 3 ln 3x plus c lah. Okay, so you can always double check if you want to differentiate, you akan dapat juga balik 1 over 3x. Okay, so that's the correct answer. All right, so now everyone, okay, so it comes to the next subtopic, okay, which I believe this one is kind of very, very important, because when it goes to, as far as I know, so all of the targeted participants are diploma students. So integration by substitution is one of the very, very crucial technique in integration in order to, to solve many of the problems when it comes to your bachelor's degree. Okay, so hopefully you can, focus more lah, all right, in this section, is integration by substitution. Okay, so in what case we have to use the integration by substitution, all right? So you can see, sometimes, all right, many integration problems, they are not expressed in such standard form. Standard form maksudnya standard form dalam table of formula lah. Maksudnya tadi tu yang kita refer to integration of what equals to what, okay, differentiation of what equals to what, that one kita panggil standard form lah, standard form. Sometimes soalan yang diberi dia memang tak ada macam tu senang. Maksudnya dia bukan macam easy, just like you can refer to the tables of formula and then straight away you can get the answer. Sometimes we need to use some technique which we call it as the substitution. All right, there are many techniques of integration. Substitution adalah salah satu, integration by parts, integration by tabular method, all right, partial fraction, okay, so many lah, Laplace transform, all right, you can also perform, okay, many things lah you can solve also. Okay, so basically we are going to deal with first some basic theory in the substitution technique lah. Okay, so what we have to do, we have to convert the integral into a standard form before we can integrate it. And how we are going to do is called by substitution. Alright, substitution. Alright, so now, procedures in using integration by substitution. Alright, so in the notes inside, okay, the book, so here are the steps lah, okay? So this is a general guidelines for all of you to go along with the substitution technique lah. So what we have to do is you have to tackle the questions. Alright, so the question, you have to make the correct substitution. And sometimes the question, you can have more than one substitution. Alright, sometimes, and especially I would say in substitution, for example, the challenging part is actually the trigo substitution lah. All right, trigo substitution. But I believe it's not in your syllabus lah. Okay, so the first step we have to do is we have to make a substitution which we let a u to something. We let u to become something. Okay, to become something. And that something, that is a hint here. Usually, when you want to use, usually, but I would say it's usually, not every cases, but usually, we will let the u to become the things at the denominator. Atau, we will let the u be the terms with the higher order. Atau, we will let the u be the terms inside the radical. For example, kalau soalan dia integrate something lah, square root of something. So biasa saya selalu cakap memang usually, because not 100%. Okay, usually kita akan ambil benda dalam square root ini sebagai our substitution. But you need to do some reverse thinking. If you let benda tu sebagai u, kalau saya differentiate, boleh tak saya jadikan benda yang kat luar tu sebagai substitution as well? Okay, so ini you need a little bit of the techniques lah. Okay, so after you use the substitution, you let u become something. The next thing is you have to differentiate the u with respect to dx. Okay, meaning to say you let u to become, let's say, let u to become sine x. So du will be equals to, du dx will be equals to differentiation sign, you get cos x. Okay, like this. That's the first step. Second steps. Next, we proceed to the third step, that is to substitute u and du dx to the integral and simplify. Okay, here there is a thing that you need to bear in mind. Selepas substitution, all the terms are now in terms of u. Okay, tak ada lagi y. Alright, okay, after substitution, kita substitute u in terms of x atau in terms of y. Contohnya kalau saya let u in terms of sin x, okay, so semua selepas substitution, all the terms of x will be removed, leaving only u sahaja dalam tu. Okay, so after only then you can start to integrate. Okay, and finally one more step is bila you dah habis integrate, you kena substitute balik u with respect to the x. Okay, in terms of x. Okay, so without further ado, okay, kita take an example. Okay, kita take an example lah. Alright, so kalau macam ni, alright, so integration of 5x over x squared plus 1 dx. Okay, so in this case, kita nampak dia mestilah is a rational function, meaning to say dia adalah a fraction lah, a fraction. So masih ingat tak tadi kita kata, so the hints is you should let the u to become something at the denominator or something inside the radical function or something with the highest degree. Okay, so in this case, kita kena fikir. In this case, first of all, ada student yang dia akan let the u to become x squared. Okay, which I believe is not going to work lah for this example. Okay, kalau satu tu kat atas mungkin boleh lagi, tapi kalau satu kat bawah memang tak boleh. Alright, so you have to let the things at the denominator as the u. Dan you cuba fikir, kalau saya pilih x square campur 1 sama dengan u, bila saya differentiate the x square campur 1 itu, saya akan dapat something related to x tak? Something related to x dx tak? Kalau ya, kalau betul, maksudnya it means you are doing the correct substitution lah. Okay, contoh, I let the u to become x squared plus 1, which is the denominator. Alright, which is the denominator. Alright, so next step, du dx. Kalau saya differentiate benda ini, saya akan dapat 2x sahaja. Okay, 2x sama tak, term sama tak dengan sini? Kalau sama, sini ada x, it means that this substitution is going to work. But let's say kalau you substitute sini x, tapi sini benda lain. Sini katakanlah square root x, katakanlah. So which means ini you differentiate, you tak akan dapat square root x. So in that case, you cannot use the substitution that you propose here. Okay, so that's the thing lah. Okay, so from here, okay, means that kalau kita dah differentiate, kita dapat 2x, which is actually similar term to x. Kita nak tengok x je. Constant tak kisah, sebab constant tu kita boleh pindah keluar, kita boleh masuk ke dalam. Okay, so constant is not important. Constant you can play around with. Okay, but you have to look at the degree of the x. The degree of the x is to the power of 1. This one is the degree of x is to the power of 1 as well. So meaning to say this assumption, substitution is definitely correct. And it is going to work. Okay, next. Apa yang kita kena buat? Kita kena jadikan soalan ini substitute by the u. Maksudnya kita akan tukar semua x menjadi u. Dan u adalah in the standard form yang kita nak. Okay, so now kita tengok. Alright, so from here, kita nak substitute the first is 5x dx sebenarnya. 5x dx, alright? Meaning to say, sebenarnya soalan ini adalah integrate of 5x dx over x square campur 1. Jadi sekarang ni, macam mana saya nak substitutekan 5x dx ini? Okay, so sebenarnya dia depends pada you lah. Kalau for me, biasanya I will take it out the 5 in front lah. Okay, so mungkin saya letak in front 5x. 5 integration x dx over x square plus 1. So in this case, you kena fikir ini. So now, macam mana kita nak substitutekan x dx ini? So from here, kita tahu du is equals to, kita darabkan dx ke atas, kita akan dapat 2x dx. Okay, and therefore your x dx is equals to du over 2 is equals to x dx. So you substitutekan ini masuk kat sini sebab ini adalah x dx, ini pun adalah x dx. So it means that you are going to have 5 integration of du over 2. Kalau again du over 2 dia constant kan, so pindahkan dia keluar supaya you tak confused. So you take it out, so you get like this. Okay, after that over x square plus 1. X square plus 1, you already let it be u kat sini. So maksudnya is u here. Alright? So meaning to say now, it is very clear is 5 over 2 integration of 1 over u du. Okay. So sekarang you tengok, every terms inside here already being substituted by u. No more x. Sudah tak ada x selepas substitution. You have to remember, before you integrate, make sure that every terms you substitute, all will be gone. Semua x akan diganti dengan u. Sebab kebanyakan common mistakes among student is, before they integrate, dia akan dapat macam contoh macam ni. Integrate 1 over x du macam tu. So here is x, here is u. Okay, kalau ini constant, no problem. Integrate of 1 over 2 du, you can dapat 1 over 2u, no problem. But now is the x is still variable. U is also variable. So basically, if you want to integrate, is definitely cannot. Unless you use implicit lah. Okay? But, which is in our syllabus, salah. Dia bukan salah lah, maksudnya, dia tak boleh integrate. Sebab sini variable dia x, sini integrate dia u. So, tak boleh. So, in this case, what we have to do is, kita kena pastikan kita tukarkan x ini, substitutekan dia in terms of u sebelum kita integrate. Okay, so now if you look at here, now you can see here, here is u, here is u. Yes, no problem, you can go ahead. So integration of 1 over u with respect to du, basically you akan dapat 5 over 2 ln u plus c. Okay, and therefore is 5 over 2 ln. The last step, you kena substitute balik what is your u. Your u daripada sini, your u is actually x square plus 1. So it's actually substitute back x square plus 1 plus c. So this will be the correct answer for example number 6. Okay, so now everyone, boleh faham ke untuk the first example of substitution? Boleh faham?
Boleh.
Boleh ya? Seorang je respon, yang lain okey tak?
Okey je.
Boleh.
Okay.
Okay. Okay, thank you very much. Okay, so now we go to this one. Okay, sama juga soalan ini, that's why tadi saya kata, kalau soalan macam ni, integration of 4x minus 2 to the power of 2, basically, dia boleh ada dua cara. Satu tu, firstly you expand lah, 4x tolak 2 darab 4x tolak 2. So, you akan dapat 16x square minus 16x plus 4. Alright, you boleh buat macam ni, no problem. And then you integrate lah, no problem. Okay, so, tapi kalau nak guna substitution, boleh juga. Okay, kita compare answer nanti kita guna sini. Okay, kita guna substitution. Kita let U sama dengan something with the highest degree. In this case, it is very straightforward lah. You boleh let U sama dengan 4x tolak 2. Sebab apa? Kalau you differentiate 4x minus 2, basically you will get 4. 4 is no more x outside. So basically that's the correct one lah. Okay, so actually saya kat sini saya macam dengar azan lah. Saya perlu stop sekejap ke untuk habiskan maksudnya tunggu azan. Stop sekejap boleh?
Boleh.
Boleh.
Okay, alright, I stop for a while lah. I stop for a while. Okay, everyone. So, everyone, can I proceed? Boleh saya teruskan ke?
Boleh.
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 Alright, that's good. Okay, thank you very much for your response. So let us continue, yeah. Okay, so tadi saya kata, okay, we have to let u to become 4x minus 2. Okay, why? Because if we, that means if we differentiate 4x minus 2, basically we are going to get a constant 4 only. So meaning to say here, kita tak ada apa-apa lagi yang melibatkan x. So meaning to say, yes, we can proceed with the substitution u is equals to 4x minus 2. All right. So next, what we have to do, step number 2, du over dx, or usually I will write like this lah. Du is equals to 4 dx. All right. I personal preference lah. Okay. Saya suka tulis terus dx dekat belah kanan Okay. Once I get this already, next, what we have to do is we have to substitute into the original question, meaning to say integration of 4x minus 2 square dx will now become 4x minus 2 is u. So now it become u square over, now kita nak dx. So dx from here, the dx is equals to du over 4. Okay, it means that dx kat sini akan disubstitute menjadi du over 4. And since I mentioned just now, not to make you confused, the constant you can straight away put in front of the integral. Okay, so it's 1 over 4 integration of u square. So meaning to say is 1 over 4 u to the power of 3 over 3 plus c. And finally, what you have to do is you have to substitute back what is your u. So your u is 1, so here become 1 over 12. So u to the power of 3, that means it's 4x minus 2 to the power of 3. Okay, and then plus c. So this will be the correct answer. Okay, for this question. So that's the correct way lah. Okay, sekarang ni tadi saya sebutkan, actually we can do this if you expand with respect to dx. Basically, what do you have? You try to have a look. 16x to the power of 3 over 3 minus 16x squared over 2 plus 4x. Okay, plus c. So basically, kalau you expand ini, so basically you are going to get the same thing here. Alright, if you don't believe, you can try. You can try. Okay, so that's the case lah. For example, you take this one, 4x multiplied by 4x multiplied by 4x lah. So 16 multiplied by 4 is 24, 64. So 64x cubed. 64x cubed divided by 12. Basically, you are going to get 16 over 3. Okay, that's correct lah. Okay, so you can try to double check. So from here, I would let you know that one question, basically you have more than one way to solve. Don't just limit yourself to one method. Perhaps there are several methods. Okay, so please wait for a while. My aircon suddenly is not functioning. Let me wait for a while. Okay, all right. So next we go to the next example, which is example number 8 here, yeah? Okay, so example number 8 here, the questions looks like very complicated and it might make you, some of you make you shocked for a while. Okay, but if you look at here, basically you try to analyze this question. So you can see first is x to the power exponential x multiplied by 1 plus 2 exponential x to the power of 4. In this case, everyone, when usually kalau kita ada soalan yang sebenarnya power more than 3 je, biasanya saya tak akan galakkan student saya untuk expand. Sebab first, dia adalah time consuming. You nak expand 4 kali. Okay, darab lagi. So total you akan darab 3 kali lah. You kena darab 3 kali lah. So and the possibility to make mistakes is also very high when the power more than 3 lah. Usually kalau saya nampak je power to the power of 4, memang saya akan terus bagi tahu student saya, you fikir untuk guna substitution. Okay, so in this case, alright, it is very straightforward. Masih ingat tak? Tadi kata, kalau you nak substitution, dia mesti something dekat denominator, atau something dekat square root, atau something, alright, with the highest power. So in this case, we know that, alright, the highest power mesti benda dalam bracket or benda dalam square root, benda dekat denominator. So in this case, you try to look again. Sebelum kita let it be substitution, you bayangkan dulu, kalau saya let u become 1 plus 2 exponential x, kalau saya differentiate this thing, saya akan dapat apa? Saya akan dapat exponential x. In terms of constant tak kisahlah, tapi kita akan dapat exponential x. So exponential x sama tak dengan sini? Sama. So meaning to say, basically it is going to work. Okay, so what can we do? We do step by step. So we let u to be the things inside the bracket with the highest power. So we let u to become, okay, we let u to become 1 plus 2 exponential x. Okay, therefore, du, all right, is actually differentiation of this thing with respect to x. You are going to have 2 exponential x dx. You can see here, basically, this term, exponential x dx is actually sama dengan exponential x darab dengan dx ni. Dua term ni. Alright, so meaning to say, you know already from here exponential x dx is equals to du over 2. So therefore, you can play around with the substitution for this question already. So this question, after the substitution, you will see, okay, macam tadi saya katalah, exponential x darab dengan dx. Ini adalah du over 2. Du over 2. As I mentioned, du over 2, so it is a fraction on the constant, right? Constant 1 over 2. So you take it out, so you get half du. And then multiply by this thing. Don't forget to multiply by this thing. Ini dah settle, tapi ini belum lagi. So ini, what does it? So it's actually, we already let u to become 1 plus 2 exponential x, right? So here will become u to the power of 4. Sebab dia adalah ini to the power of 4. Okay, so therefore you become u to the power of 4 du lah. So therefore you will get half and then u to the power of 5 over 5 plus c, which is actually 1 over 10. And then substituting back, what is your u, which is 1 plus 2 exponential x to the power of 5 plus c. So this will be the correct answer. Okay, so basically I believe kalau you dapat determine the correct substitution, biasanya you have no problem. Okay, you have no problem. Okay, cuba bayangkan kalau saya let the u to become exponential x. Du is equals to exponential x dx. Okay, you cakap boleh sebab sini exponential x darab dengan dx. Betul? Tak ada masalah. You akan dapat du. But what if here? You akan dapat integration of 1 plus 2 darab dengan u, the whole thing to the power of 4 with respect to du. Boleh, you nak solve boleh, no problem. Tapi kat sini, okay, tak ada masalah. You nak solve boleh je. Sebab you boleh guna the power rule, okay, 1 plus 2u to the power of 5, alright, over 5 multiplied by 2, meaning to say is 1 plus 2u to the power of 5. Sebab 4 campur 1, okay, which is 5 over 5 multiplied by the differentiation inside here, which is 2, and then plus c. So you can see here, so you are going to get back 1 plus 2u. Your u is exponential x to the power of 5 over 10 plus c. So basically, no problem as well. So kalau you nak guna ni, tak ada masalah pun. Yang penting adalah when you let u sama dengan something, you differentiate something, dia akan relate balik kepada soalan kita. So in that case, no problem. Tengok, kalau saya let u equals to exponential x, here I let u to become 1 plus 2x, 2 exponential x, jawapan dia sama sahaja. Sama sahaja. Alright? So substitution is very, very interesting because there are many possibilities to come up. Okay, so now I need to move a little bit faster again. Alright, so example number 9 here. Integration of sine x over 1 minus cos x. Okay, so now, okay, kalau kita nak senang, ingat je, okay, substitution, the u must be something at the denominator atau something with the highest degree or something in the radical function and so on. So, maksudnya sekarang ni, kalau kita tengok je, tak perlu tulis dulu, you fikir dulu, kalau let u sama dengan 1 tolak cos x, du dx you dapat apa? You akan dapat sin x, which is this one. So meaning to say, definitely the simple one is you let it be 1 minus cos x. Okay, 1 minus cos x. Okay, so you let u equals to this one. So du is equals to, so differentiation of this one, you get sin x dx. So from here, we can rewrite our solution after the substitution. So sin x dx, iaitu sini, dia akan jadi du. So du over 1 minus cos x, which is u. Okay, so meaning to say soalan ni jadi senang je, which is ln u plus c. So meaning to say substituting back what is your u, that means it's ln 1 minus cos x plus c. So this would be the correct answer. Okay, this would be the correct answer. If you don't believe, kalau saya differentiate benda ini, saya akan dapat 1 tolak cos X dekat bawah. Atas tu differentiation of 1 minus cos X, I'm going to get differentiation cos negative sign, right? Negative, negative, it become positive. So it's sin X. So dapatlah sebiji sama. Okay, dapat sebiji sama ya. Okay, so that's the thing lah. Alright, that's the thing. You can try. Alright, you can try. Okay, let's say soalan ini you nak tukar, you let U sama dengan sin X, you boleh cuba. Kalau you nak let U sama dengan cos X, you boleh cuba. Alright, you boleh cuba But for me, kalau you let U sama dengan cos X, macam tak boleh jadi. Sebab 1 tolak U kan. Okay, so you can try your own because due to the time limitation, alright, because I don't want to drag the whole schedule. So let me proceed a little bit more. Okay, so you boleh try by your own. You boleh let U sama dengan sin X, you boleh let U sama dengan cos X, dan you cuba. Alright, sebenarnya it's very funny lah and it's very interesting. You can try to do. Okay, next I go to example 10. Okay, integration of sin X cos to the power of 4X dx. This one, sebenarnya dia ada rules dia. Okay, sebenarnya dia kena tengok dia punya power ni even ke odd. Alright, tapi sebenarnya for in our syllabus, tak apalah. Kita hanya bincang dia punya correct substitution sahaja. So, we let U. Okay, you nak let U sama dengan apa? Okay, masih ingat tak? Kalau tengok soalan ini, dia tak ada fraction, so it is definitely no denominator lah. Okay, dan dia tak ada square root, so maksudnya the only possibility is you tengok apa yang ada pada highest degree. So, highest degree adalah cos X. Okay, so you mungkin akan tanya, boleh tak saya guna cos to the power of 4X? Okay, kita cuba kita tengok. Kalau du, kalau kita differentiate ini, kita akan dapat apa? Cos to the power of 4X. Okay, so kita akan dapat 4 cos to the power of 3X darab dengan negative sin X. Okay, so in this case, alright, tengok sini cos to the power of 3. Alright, so ini you akan substitute jadi U. Tapi sini you dapat sin X, bukan sahaja sin X, you ada lagi cos 3X, cos to the power of 3X. So meaning to say, dia akan menyebabkan selepas substitution, dia akan jadi lagi complicated. Okay, so basically dia tak akan berjaya, bukan tak akan berjaya lah, maksudnya it's not a correct substitution. Ingat the golden rules. If you want to use the substitution, it means that after we the substitution, the integration will become more simple. Bukannya lagi rumit. Kalau selepas substitution you dapat lagi rumit, it means that you are choosing the wrong substitution. Okay, so kalau macam ni you substitute, okay, you akan dapat apa? Cuba kita akan dapat sin X dx. Okay, sini dx Okay, so sin X dx dia akan dapat negative 1/4 cos 3X over du lah, maksudnya macam ni. Because from here, we know that sin X dx, you akan dapat du over negative 4 cos cube X. Kalau macam ini, tengok, kalau sin X dx ni dah lah complicated. Cos to the power 4X is U. So maksudnya dah U kat sini. Tengok, selepas substitution you dapat benda ni. Okay, dan benda ni, sini masih ada terdiri pada X. So which means you cannot integrate dah. Sebab sini U, tapi sini X. Tak boleh. So you kena fikir lagi macam mana nak jadikan ni. So you kena jadikan dia supaya dia jadi 4th root of U. Okay, dia akan jadi 4th root of U. Okay, dia sama dengan cos X. So cos cube X, dia akan jadi U to the power of 3/4 lah maksudnya. So dia akan jadi semakin complicated. Dia akan menjadi semakin complicated, which means itu adalah substitution yang tak betul. Okay, so hopefully you can get what I mean because saya dah bercakap dengan laju lah, okay? Bukan mengarut tapi bercakap dengan laju lah Okay, so the correct substitution for this is kita hanya let U become cos X. Sebab kita tahu ini nanti akan jadi U to the power 4. Dan kalau du, dia akan jadi negative sin X dx. Dia jadi macam ni pula, sini pula. So dia akan jadi senang kalau kita let U to become the cos X. Okay, so therefore, we will use U is equals to cos X. Therefore, this will become integration of sin X is sin X dx. Maksudnya sini, sin X darab dengan dx, dia akan dapat negative du. So, it's negative du here. Multiply by cos to the power of 4x. It means that is u to the power of 4. So meaning to say you'll get negative u to the power of 5 over 5 plus c, which is negative u, which is cos to the power of 5x over 5 plus c. So that's the correct answer lah. That's the correct answer for this example number 10. Okay, so let me move on. Move on a little bit for the, I think this is the last example. But actually, I got prepared some extra example for trigo substitution. But it seems like since it's not in your syllabus as well, so I think that one I just keep it up. Okay, so now for this question, last question. So you can see here, this question is very interesting. You see there is an x, there is a cos x squared, there is an exponential sine x squared. Okay, so now you have to relate yourself. So if I want to get, okay, if you let it be, you must let it be sine or cos lah, betul tak? Sebab bila differentiate sine, you dapat cos. Bila differentiate cos, you dapat negative sine. Kalau you let it be x, memang tak akan lah. You let it be x, kalau you differentiate, you dapat satu je. So you tak akan dapat cos and sine. Okay, so now when the question like this, everyone, so satu lagi saya nak top up. Selain tadi, kami katakan, kalau nak pilih substitution, sama ada substitution tu is the term at the denominator, atau term dalam square root, atau term dalam cube root, atau term with the highest degree. Satu lagi ialah the power of the exponential. Okay, the power of the exponential, ya. Okay, the power of the exponential. Maksudnya, the power of exponential tu boleh jadi you punya substitution. In this case, we let u lah. Sama dengan sin x squared. Okay, kalau kita differentiate du, we are going to get differentiation of sine, you get cos x squared. But don't forget, you have to multiply by one more term, which is the differentiation of x squared, which is 2x and dx. Okay, so in this case, you know already, x dx ini boleh di-substitute by the term. And this one, cos x squared, boleh juga. It means that dia akan jadi macam ni. This term is actually the du. Alright? Du over 2 lah sebab sini ada 2. Okay? Atau saya tulis sini cos x squared darab dengan 2x. Darab dengan, bolehlah darab dengan 2x dx. You akan dapat du. It means that du bagi 2, you akan dapat x cos x squared dx. Nampak? Sama dengan sini. Cos x squared dx ini. Alright? So, meaning to say you leaving only this term to substitute. Alright? So, therefore, you will let, after the substitution, it will become integration of du over 2. Again, du over 2, saya prefer to put in front lah. So, it's 1 over 2 du, and here become exponential to the power of sine x squared, which is u. So, now you can see here, integration of exponential u with respect to du is very simple in the standard form. So it means that kalau kita integrate exponential u, kita akan dapat balik exponential u. Okay, plus c. Therefore, our correct answer is 1 over 2 exponential sine x squared plus c. Okay, so that's the correct answer. If you don't believe, again, kita differentiate. Kita cuba differentiate. Kalau kita differentiate, so kalau kita nak differentiate exponential, kita kena drop down the sign lah. So kalau kita differentiate sine x squared, what you have? You have cos x squared multiplied by the differentiation of x squared is 2x multiplied by 1 over 2 and then multiplied by exponential sine x squared, which is you akan dapat x cos x squared exponential sine x squared, which is exactly same as our question. Okay, so that's the correct answer lah. Okay, that's the correct answer. Okay, so basically, as what I mentioned just now, I got some prepare one more question regarding trigo substitution, but seems like it is not in your syllabus as well. All right, so I think I keep it. Okay, so summary of today's lesson. So integration is actually a process of the antiderivative. It's actually the reverse process of the, the differentiation lah. Okay, the reverse process. So actually, integration is very powerful because when I look at your syllabus, later on you will use the application to find the area, to find the volume, and so on. Okay, so I would tell you integration, please make sure that you try your best to learn integration because it is very powerful. Okay, so for example, if you want to find the angle area under the graph, okay, area under the graph, basically here A and B, right? So basically you can find the area under the graph by using integration, and you will learn it in the next chapter. And if you want to go for more advanced relation of the integration, you can go for Green's theorem. Okay, Green's theorem is actually Green's theorem is a powerful theorem lah. I use this in my research as well. So Green's theorem basically it relates the line integral with the double integral. Meaning to say integration dia bukan sahaja integration, tapi dia ada integration line integral, clockwise, anti-clockwise, and you have double integral, you have triple integral, and so on. So integration is very, very powerful. Okay, and it can actually be applied in our real life as well lah. Okay, for example, find the volume. Okay, you want to find the volume or you want to solve some problems involving some physical quantities, you can also solve by using integration lah. Okay, so I think it's almost time and I'm not pretty sure whether there is a Q&A session. So I think with that, I end my presentation and my sharing now lah. Okay, thank you very much, and I pass back to Mr. Yasa, see whether there will be some Q&A session. Okay.
Okay, thank you Dr. Ang for a very wonderful class session just now. So kita berharap semua pelajar dapat faham dan boleh hadam semua apa yang diterangkan oleh Dr. Ang pada hari ini. Jadi kita open juga kepada semua untuk bertanya soalan. Jadi you boleh either you open your mic to ask or you can ask. So ada dah angkat tangan tu. Muhammad Amin Iskandar, kalau nak tanya boleh buka mic untuk tanya.
Sir. Where can I get the slide?
Oh, you nak dapat slide Boleh, tak ada masalah. Nanti saya macam mana saya nak send pada siapa? Saya okay je to share, no problem.
Rasanya boleh send pada Dr. Farah ni. Nanti Dr. Farah akan share pada kami lah.
Boleh? Nak yang with annotation ke tak ada annotation? Nak yang saya tulis ke nak delete annotation?
Nak yang ada tertulis.
Nak yang bertulis Okay, boleh. Tak ada masalah. Boleh.
Thank you, sir.
Welcome.
Okay, so any other question? Boleh guna ruang chat juga untuk bertanya kalau tak nak buka mic. Ada?
Hello, sir.
Ya.
Nak tanya, biasanya kenapa lepas loan tu ada modulus?
Oh, kenapa loan ada modulus? Okay, ini soalan yang bagus juga. Okay, sebenarnya memang loan X tu dia memang define untuk positive value. Okay, dia boleh tengok banyak perspektif lah. First, you boleh tengok graph. Okay, kalau yang paling senang, okay, you tak boleh bayangkan graph, you ambil calculator je. Cuba you tekan ln -1, apa yang you akan dapat? Ln 1 sama dengan kosong kan? Ln -1, apa yang you akan dapat? You akan dapat net error, betul tak? Sebab dia memang tak define, okay, untuk negative value. Okay, you can look at the graph, okay, the graph. So basically dia memang kena pada positif sahaja. Sebab dia punya domain memang dekat positif. Boleh faham ke? I know. Atau you nak I guna Desmos untuk plot the graph? You can plot lah the graph of ln for, dia akan menanggap macam tu. So dia memang positif je. Kalau kat negatif dia memang tak akan dapat. Dia tak akan dapat. Sebab graph, the nature of the function lah. Okay?
Thank you, sir. Rasanya cukup jelas.
Okay, alright. Okay.
Any other questions? Ruang chat belum ada.
Okay. Atau sekarang saya kat sini memang ada graph. Kalau saya guna Desmos senang lah senang saya guna maksudnya graph kat sini lah. So basically kalau you nampak sini Alright, this is the graph of y is equals to ln x lah. So basically you can see when dia approaches 0, okay, dia memang kena guna limit. Okay, dia memang kena guna limit dan you can memang nampak yang graph dia memang tak akan define untuk the value of domain when x is less than 0. Memang tak mungkin. Sebab memang macam itu dia punya graph. Dia punya graph memang macam ni. Okay, the right hand side, the left hand side memang undefined. Memang tak ada. Sebab dia memang dah going to asymptote dia memang sama dengan kosong. Boleh ke Miss Ainur just now?
Okay, Ainur faham dah
Okay.
Okay, so kalau memang dah betul-betul tidak ada soalan, okay, this is last chance you nak tanya Dr. Ang. Kalau lepas pada kelas you boleh tanya kami je kat kelas. Okay.
Biasa you lagi power je sah, tak apa.
Okay, so kalau tidak ada sebarang soalan, jadi terima kasih kepada Dr. Ang telah meluangkan masa untuk berkongsi ilmu sedikit kepada pelajar-pelajar kita. Okay, pelajar-pelajar sebelum keluar jangan lupa untuk mengisi link kehadiran dan borang maklum balas yang telah di-share oleh Dr. Syafa di ruang chat. Okay, jadi pastikan isi sebelum keluar. Jadi sekejap. Okay, ada permintaan untuk mengambil gambar semua. Okay, jadi kalau dapat untuk on kamera masing-masing untuk mengambil gambar. Require access. Oh, untuk buka kamera.
Tak, untuk link kehadiran. Link kehadiran dan borang maklum balas tu kena require access.
Oh, link kehadiran require access, nanti ada Dr. Syafa akan settle kodenya tu. Okay, jadi untuk ambil gambar. Okay, kalau dapat buka kamera. Jadi saya tak tahu macam mana nak buka page sebelah, jadi saya nampak apa yang di depan ni je lah. Okay, boleh buka kamera untuk kita screenshot gambar-gambar.
Hi Dr. Ang, how are you?
Hi Dr. Samsatun. I'm fine. How about you, Doctor?
Okay, fine too.
Sihat lama saya dah lama tak segamat.
Lama tak jumpa Dr. Ang.
Itulah, lama tak jumpa dah.
Ada raise a hand. Okay, so kita akan ambil screenshot. Okay, 1, 2, 3. Sekali lagi. Okay, 1, 2, 3. Keluar thumbs up pula tiba-tiba tu. Okay, freestyle. Freestyle lah depan kamera masing-masing. Okay, 1, 2, 3. Okay, so terima kasih kepada semua. Jadi kita boleh sudahi program kita pada petang ini dengan tasbih Farah dan surah Al-As.
Thank you Dr. Ang.
Thank you Dr. Ang. Terima kasih sebab jemput.
Thank you Dr. Ang.
Okay, so terima kasih Dr. Ang kerana sudi masa petang ini. Terima kasih juga kepada semua pelajar dan dapat hadir. So itu saja. Muhammad Farid, you?
Alright. Oh, okay. Sama-sama. Terima kasih semua sebab jemput juga. Okay, bye. Enjoy and good luck for your study.
Thank you, Doctor.
Okay. Alright. Okay.
Thank you, sir.
Sama-sama.
Thank you, Doctor.
Sama.
Thank you, Doctor.
Thank you,
Doctor.
Okay, sama.
I appreciate it so much.
Okay, welcome. So Mr. Yasa, I boleh keluar ke macam mana?
Boleh
Boleh,
dah rasanya. Tak ada apa dah. Okay, thank
Okay.
you.
Bye Esa. Bye Dr. Farah. Bye Dr. Afika. Bye Dr. Samsatun, Dr. Syafa, Dr. Ke.